maybe 2 to 3 minutes later on in the game. And to make such an important choice, you have to put lots of thought into it, and whatever you do choose, it's going to have enormous effects. Okay? Any other choices?
What about
Yeah.
zealots or expand?
Okay, zealots or expand. Although, okay, we'll see how these two interact, because the number of zealots you make for that early stage might be discrete. Like, you do make 1 or 2. You can't be like, I'll half-fast it. I'll make half a zealot. Maybe it'll attack something. Like, half a zealot doesn't attack anything. So we can say zealots versus expand, but that's good. Economy. All right, make other races.
I was going to say carriers versus removes.
Carriers or arbiters, exactly. All right, we have a room full of Protoss people. Any other Zerg or Terran?
Mutalisk or Hydratech?
Exactly. Mutalisk versus Hydrus Mass versus Lurker. So here's an example of discrete choices that have more than 2 choices, but they're still discrete because you only pick one or the other. I mean, you might think, oh, what if I pick Mutalisk and Lurker? What are you going to do? Have like 1 Mutalisk and 1 Lurker? That's not going to have any effect. So although it's a choice that you can make, it's just, has no effect. So it's not worth making. And for Terran, we can say something like mech. It's this one. Something like mech versus bio can be an example of a discrete choice as well. How about some continuous choices? When to expand. You can expand at any time you choose. So when you expand is going to be very important. What else?
How far out to scout or move anti-scouting units?
Exactly. How far to scout? Anti-scout. All right. Anyone else?
How about ratio of zealots to dragoon?
Excellent. Ratio of unit choice. I mean, technically, it is discrete because you can tell whether it's going to be 10 or 11 zealots. But let's just say for large numbers, the ratio is discrete, is continuous. So things like when to expand or attack, or to scout, how far to, or where to scout or anti-scout, buildings, attack, ratio of unit choice is excellent. Yep.
Building placement?
Yep. Where to buildings.
Oh.
And how about how to attack? This isn't actually depend. I mean, this is like a sum. I mean, this depends both on position and on time. But how to attack? How to approach an enemy?
Oh, sorry, just stand the 5 W's. Like, could you have who, what, where, when, and why for continuous?
Well, yeah. I mean, who, what,
That'd be like multiplayer for who, I guess.
where, when, why. The why is kind of difficult to quantify, so it's kind of hard to answer using what we know. But that's definitely, those are all true. So these are all important, important things to keep in mind when you're trying to make a choice. Okay. Now these choices will echo forward in time and have a great deal of effect, so to speak. So for each choice has the effect. The integral from the time you made the choice to time naught of let's say f of t. F of t, where f of t is some function. We don't exactly know what it is, But f of t is dependent on several things. F of t is greater than 0, obviously, because it has some effect. And it's always less than your production, and also less than your economy. I mean, this makes perfect sense, right? Because if you can't pay for something, or you don't have the facilities to produce it, and let's say I have 3,000 minerals, I want to make 5 carriers, but I don't have the production facilities, then I can't actually make this choice. Or economy. If I have 7 gates and off of 1 base, I can't make the choice to make 7 zealots at once. So we're not going to define what f of t is exactly, but you can just see f of t as some function that describes a range of all your available resources in the future. We'll go slightly more into f of t and how it works in vector space in just a few moments. So we're here looking at choices between, and the difference between discrete and continuous choices. So how does this equation change for discrete or continuous? Well, for discrete choices, we're going to have this this integral right here. Let's let it equal n, so I don't have to write this whole integral. So if we have this integral equal to n, then your choice is going to lead to an effect of either n or 0. Okay? So because the difference between n and 0 is so large, that's why, well, of course, these decisions have to be more precise, more exact. And we'll see, well, with vectors later. Continuous choices, on the other hand, have a continuum between 0 and n. Let's just suppose the maximum effect you can have is n, and the minimum effect you can have is 0. So you can have any range here between 0 and n, where the range is lambda times n, and we can let lambda equals the time, the current time minus the time of choice divided by the change in time. So you can be like, oh, I can scout now, or I can scout in 10 seconds, or I can scout in 20 seconds, or 30 seconds, or any number in between. However, okay, I'm going to make my choice, and I'm going to choose to scout at 6 seconds. And then we plug this 6 seconds into this lambda n, and we can see its effect on our economy, on our army, on our production, and on our knowledge, or any number of resources we may have. So the difference between discrete is that you can only choose 0 or full n, whereas continuous you can choose something in between. And this something in between is going to be really important when we talk about timing and whether or not, and we can talk about timing and just exactly when to do stuff. Yes, Kevin? All right. So now we can talk about what this means for us. If you remember back to week 2, I guess it was, with unit vectors. Well, how is certain vector? Let's call it P, the P vector. And this P vector is composed of C sub 1, C sub 2, C sub 3, all the way down to C sub m. We can see the C sub m, we can see each C as a description of our available resources. Resources could be anything you name it to be, as long as you can quantify it. For instance, C sub 1 could be probes, C2, zealots, C3, dragoons, etc. You could also name it differently. You could also say, are my income, my territory, my production facilities, or you can name it whatever you want to name it, as long as you have the appropriate method of describing it. So, well, anywhere along this path right here, since it is a continuous vector, a continuous choice, we can choose to be any direction. So let's suppose we have certain production, all right? Our production is production P. And then integral of P dt will be our total production during this time. It's going to be, let's say, n, okay? So what this tells us is that at some future time, we're going to have, excuse me, we have the ability to move n in some direction, okay? So, I mean, you don't have to produce to your limit, but it's obviously best to do so. So, I mean, this is fine and easy and dandy for us, right? Because we know exactly what we have. I have exactly 9 drones, I have a spawning pool, and, 12 zerglings. That's very easy to do. But what about your opponent? What you don't know about your opponent is the reason why you scout. So, what do we know about what do we know about our opponent? Our opponent, let's say, has a similar graph, like so. So suppose we're playing Zerg versus Zerg, right? Fun matchup. We'll start with their N1 here, and their N2 here, and their time here, of course. But from the very beginning, you have no clue whatsoever what they're going to build. They have the ability to, let's say, start drones or not start drones. So they have their entire the entirety of their quarter cone, because it is what they're able to make. So we have some future time right here, and then we have their total possible production, and then you can see how this propagates through time. So can you guys see what this would be in 3D? Some of you nodding, some of you no? Alright, looks good. So we can see our code. We see it doesn't go negative, because, I mean, who would kill their own drones? I mean, it takes a lot of micro. I gotta be honest, it takes a lot of micro. So we see it going positive in every direction. So during any of this time, we have no clue what they're doing. So that's where scouting comes in. So at the beginning of the game, we send our overlord through. We send our overlord still going, still going, still going. And voila, you're hovering over their base. You get an exact count on what they have. So instead of having a whole range of what they can possibly have, they instead are limited to a single point. You say, I see exactly 9 drones and 1 hatchery. I know exactly where their resources went. So they've gone completely up this route, up to here, and we know that their zergling vector, their zergling element, is going to be 0. Okay? So that's the effect of scouting. Now we have to discuss some more realistic examples of scouting. So suppose you're a Protoss, and you're trying to find out how many zerglings or what status the zerg is at. And then you find a certain number of drones. That's great. But you know for a fact that the possibility of their economy is a lot stronger than what they have shown. So this leads us to the fundamental assumption of scouting, number 1. Scouting. The enemy resources is composed of two portions, okay? The first portion is going to be the resources that you see. The second portion is going to be the resources you don't see. Okay? Let me repeat that. Your opponent is going to be composed of the resources you see and the resources you don't see. Sounds pretty intuitive, but it has amazing effect. So let's suppose we know that the total amount of resources that they can have is going to be somewhat greater than this. So they'll have a little quarter circle of uncertainty now. So instead of being exactly right there, we say, the zerg's got to have more than this. We'll see them as C sub, and then so we'll have a certain P, and then we'll have a certain P at a different time. So this is T now, this is T earlier, T choice. So how does our vector change? Well, we can denote P current minus P choice as delta P. And we already know what delta P is, because we already showed it right here. Delta P could either be n or 0, or it could be n through 0 for different choices. So now we have our delta P equals to 0, 0, 0, 0, dot, 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 n, 0, 0, 0, or 0, 0, n, zeros. Okay? So we have this delta t, p. And for a continuous variable, so we'll say this is discrete. For a continuous variable, we'll have delta p equal to 0, 0, whatever, c sub 1 n, c sub 2 n, c sub 3 n, 0, where c sub 1, c sub 2, and where c sub 1 plus c sub 2 plus c sub 3 is equal to lambda. So the total effect of the choices divided among the choices that you do choose to make all together will give you how much it affects, well, everything. And to be more specific, this could mean like, oh, I'm going to choose to make drones instead of zerglings, and that's going to affect my economy like so. It's going to affect my army like so. So you can denote these however you like. So this again is just a method of showing what you are talking about without any description of how it's going to affect your game. So any theory that has no application is not worth it. So what we can do now is we can see its applications. Oh, new board or old board? Alright, we'll put it here. So everyone have this down? So if we have our p vectors, well, expressed as a vector, we can show them graphically. Let's take an example, something we can actually use. For instance, this is our timeline, okay? Demonstrates going forward in time. And we call this n1 for our axis, our dimension 1, and n2 for dimension 2. So let's take our z vector, okay? Zerg vector. And we'll make it very simple. We'll make it drones and zerglings. Okay? Because, I mean, this is as simple as it gets, because each action on drones or each choice on drones or zerglings affects the other one directly. They have a direct relationship. That's great. Okay. So, what can we say about the initial condition? Well, at time equals 0, we're going to have 4 drones, right? So let's say we start right here. And then, at some further time, or at some other time, let's say right here, we have 9 drones. So, at a certain time, we're going to have 9 drones right there. Can be represented like so. And then at some future time, we can have a choice of how many zerglings and how many drones. This can be demonstrated as such. So if we express time as going up, we can draw a time vector there, and we can say, oh, how much production do we have? Well, we have the ability to produce up to this many drones or this many zerglings. And then anywhere along this path, so they can either have slightly in here or slightly in here. So they can have any amount in this little corner of uncertainty. We can denote this as R sub U, where R is uncertain, and the vector to the point itself is going to be R. Okay? So essentially, your opponent can have R vector plus R sub U vector magnitude multiplied by some direction. Okay. Does everyone know what R is? Man, you guys are tired. Then RU then would represent the uncertainty, the magnitude of the uncertainty. How much of their army, or how much of their resources that you know they must have, but is missing. And then the U vector, this uncertainty vector, would be in which direction did they choose to go in their uncertainty. Yes?
Shouldn't we assume that they're always on the most efficient frontier?
Yes. I mean, if you're playing a good player, then it's the middle is removed, and it's simply the outside line. It's a great observation.
You seem to be drawing these as arcs. Shouldn't they be just straight lines?
If you get down to it, yes. It's a lot simpler to calculate when you're approximating them as arcs. But technically, you're right. They could be up to here and up to here. And we can have this as r sub u. And then we can have this, crap. And there. Okay?
No, I mean, it'll be one straight line. Because, for example, somewhere in the middle,
Oh,
you can't have, like, if you're going between drones and zerglings, or,
okay, got it. Yep,
Yeah.
you're right.
Doesn't that represent resources used? The radius?
The radius? Yeah. But the difference is in, let's say, math, the resources, the magnitude of the resources is the sum of all these squared, whereas for us, it's just the sum of all of them. For instance, our drones and zerglings, if they're C1 plus C2, the magnitude of them is simply that. If this was actual like three-dimensional space and math, so to speak, the total amount would be C squared plus C1 squared plus C2 squared equals C total squared. Okay, and using pure vector spaces, this isn't the case. We can just say I mean we know for a fact that C1 plus C2 because the number of drones plus zerglings, well, drones plus 2 times zerglings has got to be equal to this number. So perfect, very good observation. So to recap what we just been talking about. When you're playing against a good player, then your opponent's going to be along this very outside line because they're going to be on the very edge of development. And also this is a straight line because the sum of where it is on the N1 and N2 axes describe how much there is. Good, very nice.
What is your equation?
What?
R vector plus RU.
Oh, okay. Are we back in here?
Yeah. What do you mean by that equation?
What?
What do you mean by that equation?
Okay, so R observed is what you can physically see, okay? And you also know that there must be some other resources that you can't see. So by 1 and 2. So their total R is going to be some unknown, but it's going to be composed of something you can see and something you can't see. So we can say the magnitude of what you can see and the magnitude of what you can't see put together equals the calculated magnitude of all the available resources that the person could have gotten. And so I guess what this is the true vector for your opponent's resources is going to be what you observe and what you can't observe multiplied by some direction that they chose to invest in.
That's what U is, the direction.
Right.
Yeah.
Oh, that's what this U is. So whether they went here, here, or okay. Now, how does this echo forward in time? This is going to say, well, so as you go further in time, the additional amount that you could be off by is going to be like so. So this is your new, I guess you can't use radius anymore since with the corrections, but well, radius. It's going to be the new radius of uncertainty, okay? And well, this is going to be R sub u in either direction or any position along this line is going to be equal to R u observed plus the integral of f of t dt. And f of t being the f of t we discussed earlier with the limited by economy and production. So how do we get rid of this uncertainty? Because until you can observe something, until you know what opponent you're fighting against, you're in the dark, right? So you get rid of this R sub u by scouting and observing them. All right. Let's take another real example now. Let's suppose you are Protoss, okay? And you're Protoss, and you're trying to figure out how much your opponent has. This is going to be your curve, okay? Or line. Let's suppose you're going the standard Protoss build for current day, and then you want to expand, right? Everyone wants to do that. But when you're trying to expand, you have to make a discrete choice. Whether you want to go, well, not really discrete. You have to make a choice between economy over here and army over here. And obviously, you're gonna not have any mobile army, but you can pull probes off your mining line. You can build cannons. That's gonna be what we're gonna call your army for now. So when this goes into effect, your opponent has a similar econ versus army graph. Okay? And you don't know what they have. So they have some cone of uncertainty for some time. So what the point of this is, if your opponent has this, you must also have some sort of army to be able to counter that. However, if your opponent is down here, let's suppose these, each tick represents 2 zerglings. So your opponent could have gone between 0 and 12 zerglings. And you could get between 0 and 2 cannons and pull between 0 and 12 probes. Make sense? So every tick here tells you how much more army you need to have in order to counter them. So you have a choice. You can make the choice to go fast expand. Okay, so this point right here would demonstrate 14 nexus. You build your nexus on the 14th probe. And this choice would be to make forge and then cannons right away. So you have to make your choice on where to put or how much army you make based on how much army they make. And that is entirely dependent on your scouting to say, he is right here. Ah, I know I can take this instead. Okay? So this is how you can use these graphs and these equations, I guess, to predict what you can do, what you can't do, and what you can do without losing, and what you can't do because you'll lose immediately. So in the last couple minutes of this first hour, I guess what we can do is generalize it. So instead of just having 2 vectors in economy and army, or zerglings and drones or whatnot, we'll have n vectors. So we'll have your vector, let's say p. Your p, you know everything about yourself. So we just have this p. But you also know what you're going to do. So plus your delta p has to be greater than, well, at least the army of it has to be greater than, or you have to maximize your economy, or whatever you want to do with these vectors. You have to be greater than your opponent's z observed here. So one of these has got to be it.
And so I guess expanding on what that guy, why it's a straight line, the norm should be an L1 space norm instead of an L2 space norm. Go to we'll see.
I guess, so you're talking about the absolute
Yeah.
values of these.
Yeah.
Yeah, I probably should have thought this through a bit more. But
All right, that's
thank you. Thank you. Actually, thank you. It's you're correct. So the sum, we're talking about what's the sum, just pure C1 plus C2, as opposed to true arcs with C1 squared plus C2 squared. Actually, I've been working so much with that I just slipped my mind. Thank you very much. All right, so is anyone else confused? It's, the total number of resources that you can possibly have is composed of what you see and what you don't see. And so the true amount of, the true what they have is composed of what you have seen them have, plus what they don't have, times, or with a direction where they chose to invest their resources. Thank you for all the clarifications. So, I guess for contrast, we can see the following. So there's our world line. This is going to be for continuous variables, continuous choices. For discrete choices, we're going to have this. We're going to have the choice is going to be made at some time. And it's going to have 0 effect until until it takes effect, until the full end comes out. So after this, suppose this is t sub choice. After some time, t sub choice suddenly takes effect. Let's suppose this is the reaver count, and this is the dt count. Okay? So at some time, we're suddenly going to jump to here, or suddenly going to jump to here. So we see the difference. I mean, so basically the point is, there's no in-between line that you could be on. So all of these points are non-existent. So you can always, so when you're trying to defend against an enemy, discrete choice, you have to be prepared to defend against the full effect or the full effect here. So this also leads to another interesting effect of what we see in uncertainty in time. I'm going to try to get this right this time, okay? So we already have some uncertainty. And this uncertainty is going to be R sub u magnitude, okay? However, as time passes, but you can only observe what you can see immediately, right? What you cannot observe, they can do whatever they want with. So we're going to have an additional factor of the integral of either the integral of f of t dt. So our full RU, so I guess this is what our uncertainty of the observed and the calculated. But when you add in time, time change, then we're going to have the full uncertainty that you don't know about. So how this is represented graphically, yes, thus. Well, we'll have like let's take something a lot more general now. We're going to take army here and economy here. Okay. So we're not going to talk about like individual zealots, zerglings, reavers, probes, nexi, expansions, or whatnot. We're just going to have army and economy here. And then of course this is going to be our time. Let's suppose at some time you know they have a certain economy and a certain army. Let's call that T right here, okay? Where this is T choice. And also, you know that they must have something else that you don't know about. So let's suppose it has a certain, well, if you're playing against good players, a certain line of uncertainty. If you're playing against poor players, this little triangle of uncertainty. Alright, class is starting. Thanks for your patience. Sorry about those technical difficulties earlier. They seem to happen every week. Alright, and so I guess announcements. I'm still working on getting your homework graded. I've been kind of busy lately. I have, class and labs and homework and midterms, just like you guys. I'll try to get all your homework graded by next Thursday, so you can look over them over spring break. The homework for this coming week is not up yet. I'm going to see how far we get through this week, during class today, before I post the homework. So it should be up by tomorrow or Saturday. Next order of business is congratulations to our CSL team for winning once more. MIT. So Berkeley and University of Texas are the only two schools that are still undefeated so far. And so that is why we will be facing off this coming Saturday or Sunday, one of the two. This week.
What was the score against MIT?
3-2.
Nice.
Okay.
It's been 3-2 every single week, but we won. They can kiss my mouse.
Mouse.
Alright. And as far as your final projects are concerned, you have all of spring break to think about them. It'd be great if you guys could turn in a half-page little blurb on what you want to write about or what you want to research the Thursday after spring break. Okay. So with that said, let's get into this week. This week we're going to be discussing scouting and if we have time, counters. See, the problem with scouting is that we can't just talk about scouting. We have to talk about how to get there. Like, why does anyone need to scout anyways? If you're playing SimCity, let's say, okay? There's still scouting. Why would you ever send anyone out of your town when they could be in your town working, right? So we have to start with the concept of choices, okay? At any one time, you can make, any number of choices. And there's two kinds of choices. One is discrete choices, and the other is continuous. Continuous choices. Like, discrete choices could be like, are you going to have eggs or ham? You can't have both, okay? Are you going to go to Berkeley or MIT? You want to win or lose? You can't have both, right? So discrete are choices that you make that have a set number of outcomes. So you can only have choice 1, 2, 3, or 4. You can't have a range of them. And continuous, I should write them a little further apart. Continuous choices, is going to be something, is going to describe something that has a continuous variable in the world. Like for instance, how far did you run? You can measure that down to the Planck length, I guess. But you can, for all intents and purposes, it is continuous. So you can describe exactly how far you ran. It's not, you can either run 1 meter or 2 meters. You can run 1.5, you can run 1.5000 meters, or any number of meters you choose. Another variable that is continuous in this world is time. And both of these variables, space and time, are what we are going to consider as continuous in the Starcraft world. So, bringing this discussion to Starcraft, can anyone give me some examples of discrete choices in Starcraft?
Tech tree.
Tech tree. Can you give me an example?
Like, do you build the observatory or not?
Okay. Observatory or not?
Never.
Or, the thing is, well, as we'll see later, the earlier you make a choice, the more effect it has. So, I mean, observer or not is a slight directional change. What if we choose something big? Something like, do you want to go Templar route or Reaver route? So something like that, Templar archives versus robotics, is a choice that you have to make that manifests itself maybe